Yeah. Okay, so we'll start with control structure. Okay, and before we go into control structures, I'm sure many of you are familiar with if and if else, all those things. Before we go into that, there's something called as Groovy truth. Okay, so what is true or what is false in Groovy? Okay, so the notion of truth is very different than in other language. It's not just that this true or false. That's not the only kind of condition that you can check for. You can do a lot of things. What I mean by that is anything that you know in Groovy, like let's say you know int, right? Int equals to, if it is 0, okay, then this is considered, a value of 0 is actually considered false in Groovy. A value of 0, 0.0 for double or decimal or big decimal is also considered false in Groovy. Okay. If you have an empty string, this is also false in Groovy. Okay. Then if you have an empty list, let's say empty list, okay, this is also considered false in Groovy. So let me give an example of that. We were talking about ranges last day. Okay, so we can do this something like this, and this is having exactly what, how much content in it, what is the size of this particular thing, range. This is having just one. I'm iterating from 1 to 1 exactly. But if I make it half exclusive range using the angle bracket, okay, the size is actually now 0. Okay, now if this size is 0, that means this is actually false in Groovy. So now we'll start with if else and we'll see this. So if I did something like this, 1 second, okay, print line, we are in if block, else, print line, we are in this. And if you run this piece of code, it tells you that you are in int block, not in the this if block, because this evaluates to a size of 0, and 0 is actually a false in Groovy. So that is why this thing did not work. So if I just made sure that there is some content, I mean the size is something, not 0, right? Then in that case, you'll get this, we are in if block, okay? So be very careful, because sometimes what will happen, your script will eventually become very big in size. You know, the number of lines can exceed 500, 600 lines. And if you are doing something int equals to maybe 10 someplace, right? And down the line somewhere there is int b equals maybe 10 or 20, let's say. Whatever, okay. And if you had an expression such as this, b minus 2 times a, and then you thought that you are going to perform some expression here, important expression, maybe call some API, okay, then this will become a very difficult thing to debug. You will not be able to figure out what exactly is going wrong here, but it is important to understand that the expression inside if is actually evaluating to 0, which means this will never get called. So be very careful about that. All right. Any doubt on this?
If it's a minus value, what does the Boolean value will become?
That is true.
True, is it?
Yeah, minus is true. So if I did something, print, okay, print working, else print, nope. If you run this code, it will work, okay? So it is just for 0, 0, 0.0, false is false naturally, empty list, okay, empty string. If we will talk about empty collection like maps, okay, if you have a set also which is empty, that will also be false. If there is null is a special, that is also false. So you can simply check by using assert, that is I spoke about on the first date, but I didn't want to bring assert again. If you do something like this, assertion will fail, because null is actually Groovy assumes null as false. Okay. Anybody else? All right. Moving on, we'll do some if else. This is pretty straightforward. Okay. So what I wanted to do is if we'll do some kind of conditional. This is simple. So if the condition that you provide here, condition, right? If it is true, then do these things, right? Something like that. Otherwise, else, if you can provide another condition here, do these again, and then something like else, which is like the last statement, do uh, else steps something. So let's actually give a concrete example and make things clear here. Okay, so let's say I want something like a variable called age. Okay, and for the time being, let's just give it an age of 18. Okay, we will decide whether the candidate is suitable to vote or not. Okay, so we have a legal age limit of 18. Okay, below that you cannot vote, something like that. Okay, so we can say if age is actually less than 18, you can say print line. Okay, you can say you are not allowed to vote. All right, to vote, else print line, you can vote, something like this. Okay, so if you run this piece of code, yeah, you can vote because the age is actually 18. If it is less than 18, let's say it is 9. Okay, if you run this piece of code, it will tell you you are not allowed to vote. What if the age is 90? It will tell you that you can vote. Okay, so this is very simple condition here. You can have multiple this if block in something like else if you can do, and then add condition. So let's take an example for that. Let me frame one example. Okay, 1 second. Okay, so maybe we'll do some else if in here. Maybe well, if your is something like let's say is greater than your, sorry, is greater than equal to 18, and okay, is less than equal to 60, you can vote and you're working, something like that, you're working. Else we can say something like print line, you're retired and go. Okay, so we have this three condition here. If it is less than 18, you cannot vote. If it is greater than 18, and this is an and condition, by the way. So so I'll tell you, I think most of you are familiar with this thing. Okay, and which exactly is something related to logic gates. Like if this is true and this is true, then only do this thing. Okay, so
Sort of, we have to put two ands for that.
yeah, we have to put two ands, otherwise it will be bitwise operator. So bit actually works on the bit level, so that is 0 1 0 1 something on the bit level. So if you represent let's say 5 is represented exactly like what, how do you represent 5? Yeah, this is 5 representation in binary, right? So if you do and, then it actually works on bit level, so it will work on this, it will work on this, it will work on that. So that is another thing, you have to specify two
Okay.
yeah. All right. Okay. So if age is less than 18, you'll go in this block. Else if it is in between 18 to 60, you'll go in this block, and else if you're going to go with this block. So if you run this code, it is telling that you're retired, but you can vote. It is like your age is 90. So that's why if you give something like 55 and run this code, you can vote and you're working. Okay, so another thing that you can have here is or, not here actually. There is this conditional or, we call it. This is conditional and, by the way. We represent is using 2 pipe character. This what exactly does is if any of the statement if either this is true or this is true, then this will execute it. Okay. When it was and, just when it was 1 second. When it was and, you had to do both side of the code, both side of condition has to be true for that particular block to get executed. Okay. One more thing here is that if there is only one statement inside your if block, the curly braces become optional. Okay. The curly braces becomes optional. So we have just one expression, so we can do this. Okay. And this will continue to work the way you want. So if you give here age of 5, then you're not allowed to do it. Okay. But always give curly braces because that is a good practice. It becomes your code more readable. So always actually give, whether you have one block, one statement or multiple statement. For multiple statement anyway, you will be forced, otherwise you'll get some error. Even if you have one line of statement inside your if block, mandatorily give curly braces. That is good for readability. Any doubt on this one? All right. So one more thing I wanted to show, just for completeness. So we have this. You can use a scanner class also, but in Groovy we have a reader. Okay, and then read line. All right. And this will give you a string, by the way. So what I'm exactly doing here from this line of code is that I'm asking to get an input from the user rather than each time I'm changing variable here. What if the user wanted to give? So if you run this code and go to your command prompt, it is asking. So if let's say I'll give something like 30 here, 30. Why it is not writing? What? Just a second. All right. Does anybody have that code? Okay. Int is equals to system dot in dot new reader, and then you can do read line. Okay. I just want to print line is here. If you run this code here, then go here. Okay. You can give let's say 23. Okay. And 1 second, we are getting some error. Because that is I'm defining by default what is happening. No, by default, this particular thing gives you a string. Okay, so either you can cast it into this integer, something like this. You can wrap it around integer, this thing like this. Sorry. Okay, so maybe if you run this code again and give 23. Okay. 1 second. Just do it something like this as integer. This is easier. If you run this 30, it will print you here 30. Okay. So this is actually called coercion actually in Groovy, where you actually convert some data type into another data type. Okay. Just like casting. Okay.
I can use diff if I don't want to do that. Right?
Yeah. You can use def. Yes. Okay. Is this clear? You can use this code for your if else block, by the way. Okay. My thing got deleted. Anyway, any doubts so far? All right. Let's talk about switch. Switch is actually interesting in Groovy. It is used at a lot of places. Okay, so I'll give you a very simple example. Switch is just like if else. You can have multiple if else block, if else if else if else if else if else if something like that. But here you can do switch also. So let me just show quick example. So here we do something like keys. Switch has cases. Okay, just like for if else block, you have if block, else if block, something like that. You have cases here. Okay, so case 0. Okay, print line. Something like not valid. Okay. Then you can break out of it. Then you can do case. Maybe we can pass here range. Okay, so 0 to 9, maybe 0 to 10. Okay, and then you can say ask print line, is it in this range? Okay, and then break is mandatory after case. Otherwise, I'll show you what happens if you don't use break, and I'll tell you break about break also after some time. Case. Let's give a list also. 3, 4, 5, 6, 7, 8, 11, maybe 100. Okay, and then print. You can print line here. Print line. Is it in list? So basically, what we are doing is we are checking whether this 12 is in certain condition or not. Okay, so let me add a few more, and then you can do something like case float. We can check whether that number that you have passed is a float or not. Okay, so is it float? And break. And one more. Let's have one closer as well. Okay, so it percent 3 equals 0. Okay, then you can print, is it a multiple of 3? Okay, and then break. And the last one, the last something like you have in if else, the last block we give as else, which is like our fall through. Okay, you can give similar thing here in switch case. You can say print line none of the above. Okay, okay. So if you run this piece of code, let's run this. So it is telling me here, let me get me some here. Okay, it is telling me, is it a multiple of 3? Okay, because when you are testing for this particular condition here. Okay, is it 0? It's not 0, so it will not go in this one. Okay, is it in this range 0 to 10? It is not in that range. Okay, so it will not go there as well. Is it in the list that I've given? Well, it is not in the list. Okay, is it a floating point number? It is not. Is it divisible by 3? Yes, 12 goes 3 goes 4 times 12, which gives you a remainder of 0, and that is why it is saying it's a multiple of 3 here. Okay, the point I wanted to show here is that in Groovy you can have multiple objects as case statement. You can have a list, you can give map, you can give ranges, you can give closures, any objects. Okay, so that is what I wanted to discuss here about switch statement. Okay, one more thing. Let's say if I do something like 12.2, what do you think will be the output in this case?
Float.
Okay, anybody else? Any guesses? Cool. So I run this case and it is telling me now the above. Okay, so it came to this one. Why it didn't go to this one? Anyone?
Because float is not.
Begin with 12.2.f or something.
Yes, exactly. Float is actually a keyword. It's a class, by the way. The thing is, I told you by default, decimal is in Groovy is big decimal, right? So I had this 2.3 and I wanted to fetch the class of this thing. And if I just execute this particular piece of code, it tells me I'm big decimal. If I wanted to test for float, you can give small f, or caps F. It doesn't really matter. Once you do that, then it will tell you, okay, I'm float. So you go ahead with F here. And if you run this code, it is telling, yeah, I'm a float. Okay. One more thing. What if I don't use break after a case statement?
And instead of this number, if I have say int a equal to 12, then I can just write a in the switch. Right?
Yes.
Not dollar a, only a, correct?
No. If you had a equals to, let's say, 10, and I wanted to test for a, okay, then if you run this code, it is in this range. Okay. Because I think 10 is already someplace here. So
When you use dollar, when you put it inside a double quotes.
that is for a string. Yes. So now why it printed 10? Because it got it here itself, because we are in this thing. So one more interesting factor here. If you forget about break in your switch statement, let's say I forgot it here. Okay, I'm testing for A, which happens to be 10. What do you think will be the output?
It'll have the default case also. It prints the case and then it goes to default and it prints it.
Always print default, right?
No. So if you run this, it told, okay, 10 is in this range. I'm going to execute this block of code for you. So I'll print it that is in this range. Then it encountered no break. I've commented it here. So it encountered no break and it fell through to this case block. And without even checking in this one, it printed with this thing. It is in this list, but it is not in this list. 10 is not available here, mind you. Okay. It printed that it is in the list. And then after that, it encountered this break and then came out of the switch block completely. Okay. So break is mighty important when you're working with switch statement. Okay. All right. Anybody?
Why did it go to that case on the first place, Saurabh?
Because here it checked for 0. Okay, it checked for 0 and it said, okay, it is not 0. Okay, it did not go in this one.
I understood that. So
Yeah.
what I'm saying is, if you comment the 7th line break, right?
Yeah,
Line number 7, if you comment it,
yeah,
it should not come to the next case, right? Because it doesn't match, right? It's not in the list, right? It should not come over there,
yeah.
right?
It is not in the list, but even then it will execute that line.
I think it might be assuming that the next case is a part of first case.
Yes.
And that is why it is printing the following statement.
So if you skip this one also, you know for a fact this is an integer, but it will print you, is it a float as well? Okay, sorry. Okay, it's a float as well. It won't check for case if you don't have break. Okay.
Okay, so you have to accompany a case with a break to have a desired output.
Yes, a case break is very, very important if you're working with switch blocks. And there is some good thing with working with switch in Groovy as against to other languages, because you have flexibility of other objects to use in case block, which is really good. Okay, so yeah. Anybody any doubt? Okay, cool. Now we'll talk about a bit about looping. Okay. Everybody clear with if else and switch? Just asking one last time.
Yes.
Yeah. Anybody else? Any doubt? Let me know. Okay. By the way, looping, we have two construct here: for, while, the usual suspects. Okay. And this is looping in Groovy is ridiculously easy. Okay. So if I have, let's say, a string, something like S maybe, in, let's give a range here. Okay. So I want to go through all the way from E through Z. Okay. This is a for, by the way, for statement. Okay. And I don't want to do anything. Okay. I just want to print it. Okay. So if you run this code, no, it will go through E all the way through, not just through Z. Okay. It will print you this extra characters in between. And then it will start from small a and go through Z. Why did it do so? Because we went from capital A to small z. If you went from capital A to Z, that is all you will get. Okay. So in this case, we went from E to Z. Okay. So this is actually very simple. Let's actually do some kind of some better work. Okay. So okay. So let me have a string first. Okay. A string s equals to, I have a code from yesterday. Let's see, just call the working class dies of pneumonia. All right. So I have a string here. Okay. What I want to do is I want to, if I just did again, if you wanted to iterate on this one, okay, so you can say a string character, don't say char, that is a special meaning as can be seen highlighted. This actually represents character. Okay, just write ch. Okay, in s, if you printed something like this, okay, print line, actually just let's not print line this time, just print s and then plus maybe a space, okay, so that I get it on one line itself. Okay, it did something very random. Okay, wow. Okay, it is repeating it a lot of time. Not sure what are we. Okay, I'm printing s, I should be printing ch. Ch is my loop variable, right? S is this one, so it printed it a multiple number of time. Sorry. If you run this, it actually printed W then with space and then all those things. Okay, but this is not what I want. I don't want to have this character individually. I want to work on one word at a time. Okay, so how can we do something like that? Well, that's easy. You can do something like s dot split. There's a keyword on string. Okay, and if you run this again, sorry. Okay. Okay. So this is there is a split keyword on string, not keyword, split method on string. When you do this, so I'll show you what it actually does for you. So I'll define something, split, okay, and then s dot is split, okay. And what you do is you print this whatever split is there, okay. So this actually creates a list for you, okay, a list of strings from that particular sentence, okay.
Default is a space, splitting on the space.
Yeah, you can specify something. I think you can specify this comma. In that case, you'll have one as when up to this point and then from there to there. So there is only two
lists.
two elements in the list. All right. So this is how you can iterate. Okay. And by the way, the general one that you have seen so far in your Java world, int a goes to sorry, use I. You can use a, but I less than, let's say, less than equals 20, and then I plus plus, and then you can do whatever you want here. I just want to print line I. Okay, so this is the general way that you've been using. It will print from all the way to 10 to 20. Okay, so this is the normal Java syntax. This is your and this is also there, by the way, this one they introduced in Java 5, I think, for it. Okay, enough. Any doubt on that one? Any doubt on this one? This for looping.
Is that the only way you give the for, or is there multiple ways the syntax of for?
Like how exactly? Yeah, I'm not
Is
getting.
there any shortcuts or anything on the for? Something like one entire line if you want to give for. So I've seen multiple complex Groovies, but I haven't understood much on that. So just want to understand any other way of doing a for.
No. Can you provide an example?
Yeah, I'll get that example for you. I'll get that.
Okay. So, but this is clear for other people, right? We are doing simple looping. Looping is iteration. So, any doubt for anyone on this one?
No, sir.
All right. So there is another loop which we call as while loop. Okay, and while there's a difference. There's not a lot of difference actually between for and while. Okay. Let me give you an example first. Okay. So I have a variable 10. Okay, and while I'll say something like, and remember, if you specify just one, right here, and if you did something, hello, how many times this will print? Any idea?
Infinite.
Yeah, because one is true in Groovy, like I told at the start of today's session. Okay, if you give 0, no, okay, or any expression that evaluates to 0, okay, then it will not at all get executed because the condition itself is false. Okay, so if you run this part of code, nothing really happens. Okay, so let's actually change that. While a is less than, let's say, 25. Okay, while a is less than or equal to 25, print this. Now how many times this will execute?
Infinite.
Anyone?
10 times.
How? So
It's always true, right? 10 is less than 25.
so if you see this, we have defined a as 10, right? Then this code of will come for execution. This a is 10. 10 is always less than 25, right? It will print this. There's nothing in your code that is changing the value of a, right? It will go there again here, check the condition. Oh, I'm again less than 25 because a was 10 already. It will print this. It didn't do anything to a. A is still 10. 10 is still less than 25, and this will end up in an infinite loop. Okay.
Got it, got it.
Yeah. So what you can do is you can change something. You can say a plus plus or anything. Maybe a equals to a plus 3, let's say. Okay. So if you run this piece of code, it printed hello a certain number of times. Okay. And you can figure it out why it printed certain number of times based on the condition that you provided. All right. So that is actually a while loop. Okay. And just to make this more readable, always give proper spacing, proper indentation. Okay. So that your code is readable. All right. This is simple, nothing complicated here. Okay. Two things are there oftenly associated with break looping, which is your break and continue. Okay. We have seen break in switch also. Let me get some space here. Okay. So let me just get rid of this part. I don't want to run that. Okay. So let's say I want to iterate from 1 through 20, and I only want to print those numbers which are even. Okay, so the question is iterate 1 through 20, okay, and print only even. Okay, so let's see how we can do this. So you can write for loop, okay, or you can write while loop. So let's just say int I a equals 1, okay, and we can write something like while a is less than equal to 20. Okay. What do you do? Well, you can check here, right? If a percent 2 is equal to 0, you can print line a, otherwise continue. Anyway, it will continue, but let's just run this code. Okay. What happened? What happened?
1 is less than 20.
Did everybody get this point? Why it is not working?
1 divided by 2. Because it's false, right? Condition A.
No. 1 is less than equal to 20. That is true.
Then you divide 1 divided by 2, right?
This should not be 1.
Yeah.
Right? This will 1% 2 is not equal to 0, right?
Right.
So it will never go here.
Correct.
And then you are saying continue.
Continue.
Okay.
Right.
So it will go back to this case. It will go back to this one, top of the line.
Correct.
1 a is how much still? A is still 1. Okay. So you have to do something, right? A equals to, or maybe a plus plus. Okay. And if you run this code again. Okay. Okay. So I think my if you guys are also working on console, so this is the way to stop, I think, right? And then just run this. Come on. I have to close it or what? Okay.
Copy it.
Yeah, I will copy it. Script executing, press OK to attempt to interact.
I think it's running in infinite loop.
Yeah, it's running in infinite loop. No, I don't want to save it. All right. Oh. Okay. So okay, let me give you one more example. I'm not able to paste it. I should have pasted it somewhere before I close this console. Okay. Let's keep it 10. So I don't know. If e% 2 equal 0, right? Then print line e. Okay. Else, sorry, e plus plus. And then continue. Okay. Continue does not make sense here because anyway there is nothing left to do for this code of this. I'll show you 1 second. If you run this code again. Okay, 2, 4, 6, 8, 10. Okay, but if I had some statement here, print line, if I came here, right, I must be odd. Okay, will you think? Do you think this will execute?
Yes.
No, it will not execute.
Yeah.
Okay, because it actually stops from here itself. Okay, so you can do it in a statement. Let me put it another statement. Maybe e%2 is equal to 1, and in that one we can write something like this one. Control X, print line. Okay, continue, and then print line. This will never execute. All right. Okay. If I came here, it must be on something. I came here something. Okay. All right.
So continue. This is skipping the lines after
Yeah.
that.
So what exactly? Where is my? Am I on Zoom? Yeah. Okay. So let me exactly tell you what continue does. Okay. Your execution starts in your loop. Okay. The moment you encounter continue, no, it will go back at the top. Okay. By continue, don't think that it will continue to print this thing. No, 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 no. Once you execute continue, okay, it will go back at the top and start processing again. So that is the use of continue. Okay. And can somebody here tell me why it didn't go for 1 exactly here? I didn't get for 1. Can somebody tell me exactly why that happened?
A plus plus.
Yeah, this actually is a problem maker because here a was 1, right? It would have come here. It will not go because it is 1 is not even. It came here, and the moment before coming to this point, this got changed to 2, and 2% 2 equal to 0, not 1. Okay, so it will not go in this. It will go back. Then a is 2 this time. 2% 2 equal to 0. It will print this line, and it will increment this, and then again it continues somewhere. Okay. Any doubt on this one?
It's good, yeah. Not very clear.
Okay, cool. Okay, so there is another statement which is your break, and break actually just breaks you out of the loop. Okay, the use of break is to just break you out of the loop. So what I mean by that, let's say I am doing some kind of looping, even for also that is true. Okay, so maybe I had a string here, string word in, let's give a list of word. Okay, Oracle, maybe VM, Microsoft, Amazon, and then one more I'll give yeah, maybe I'll give Twitter. All right. Okay, and okay. Okay. So what we will do is that if we'll apply a condition here, okay, if word is equal to Amazon, okay, break me out of the loop, okay? Because that is how you use it. Otherwise, do me a favor and print line. They are not competitive. Doesn't make sense, but this is not a very good example, but just go with the flow, okay? So if you run this piece of code, it will come for Oracle. So first thing we have is Oracle. Oracle is obviously not our competitor. Then it came for IBM. IBM is not competitor. Then it came for Microsoft. Microsoft is not competitor. The moment it came for Amazon, it will go here, right? Because this will become true. Word is actually equal to Amazon, and then it will break. And once you encounter break, your execution will go past the loop. So this is over. And now if any code you have below your looping, this will get executed. Okay. So break actually breaks you out of the loop. Any doubt?
They will not even print not competitor, right? Break means
No.
break
Once
that-
you the moment, sorry.
break
Once
of
you
five.
encounter once you encounter break, you just break out of the loop. That's it.
From there only it will go
Yeah,
out.
nothing. It will not print anything after that. Even if you had a statement here, let's say you had print something. So somebody was saying something.
No, it is breaking out of the if loop, or it is breaking total for loop.
No, it is breaking out the loop. You are not breaking out of the condition. Okay.
If is not
Okay.
If it's not looping, right? You have loop
yes.
as for. Okay. And by the way, many people don't have a lot of doubt regarding this. Okay. If you have for, right? And inside you had a for here, nested for. This is called nested, right? And if you had if here break something, if you had condition and then there was a break, it will break out of the current loop, not the entire thing. Okay. It will only break out from the current loop. Okay. And then it will come back to here, and then processing will start again. If you do something like maybe if you wrote code for, let's say, bubble sort, right? And try writing code for this. This will actually have two loops which will be nested. Okay. And then you'll figure out that part on your own. Okay. So that is actually what do you call it? Simple. Looping constructs in
Continue also, if it is a nested loop, it will continue from that loop only.
that loop only,
Not
inner
from the
loop,
parent
not
loop.
from the parent loop. Okay. The scope is local, as much local as possible. Any doubt, anyone? Anyone? Okay. Just for completeness, I'm telling you, because in EPM scripts you'll find this. Okay. And there is something called as ternary operator. Actually, there's three things here. So unary, okay, binary, and ternary. Okay. So we have seen unary and binary. The moment you do something like 2 plus 2, this is called binary. You are working on two things. Okay. So if you run this code, it gives you 2, sorry, 4, right? We have seen unary also. Okay. If you do this, what it will do? It will print 2. Why it printed 2? If you did this, it will print 3. Remember, this is post, this is pre. Okay. Then there is ternary. Ternary is actually something like you can have some small condition here. So if, let's say, I had something, just give me 1 second. Int maybe is equals 10. Okay. So you can write if block just for checking whether if it is less than 18 will not let him vote, or if it is greater than 18 you can let him vote. So you can use something like ternary as well for that. How do we do that? You can write is greater than, so is greater than equal to 18. If it is greater than equal to, print line vote, else print line no. So if you run this code, sorry, what did I do? Okay. This is 10. Okay. So how does this work? I'll just show you in a moment here. So this condition is checked first. Okay. This is the number one thing happened. So 10 is actually less than, is 10 greater than equal to 18? Well, it is not. So if the condition will be false, if condition is false, it will come to this side of colon. Okay. If it is true, it will come to this side of colon. Okay. So for 10, 10 was actually less than 10 is not greater than equal to 18. So it came to this one. Okay. If you give something like maybe
alternate for if else.
it is alternate for if else, but if else can have multiple hierarchies. So if else, if else, if else, if else. So if you give something like maybe 25 and then run this code, then you can vote. Okay. So this is ternary operator, by the way. Okay.
Saurav, I have an example. So
Yeah.
it's again a ternary operator, right? I just pinged you in the Zoom chat.
Okay.
One of the code from
Yeah,
Groovy.
yeah, just a second. So this is your code, right?
Yeah.
Okay. 1 second, 1
Put
second.
an enter.
Let me decrease my size for some bit. Okay. So you have this thing, if customer number is not equal to null, okay, then
customer number.
you are assigning this string to this match field name. Okay. So let me actually break it down for you. Okay. Sorry. Yeah. Okay.
Customer number, right?
So there's this variable customer number that you have. Okay. If
Yeah.
that is not equal to null, I mean, if it is not equal to null, so null is actually something, let's say, I'll tell you a string s, okay? If you did something, sort of, let's say, okay, then this s is actually having this value, sort of, in it, okay? But I can also do something like string s, okay? I'll only declare it, but I'll not assign a value to it. Okay, so if I run this part here, this one, okay, 1 second. Okay,
Customer number, right? Debit plan, correct?
you can do something like this once. Okay, print line s. 1 second. That is okay. That is okay. Even if you do this thing, no, if you only declare it that, okay, I'm going to declare one variable, okay, one object, but I'll not assign anything, any value to it. Okay, this will have null into it. So for this particular one, if I replace this customer number here with s, the one I created, okay, then what it will do? Well, s is not equal to null. Is it true or false now?
True.
It's actually null. Yeah.
Yeah, s is null, right?
It goes to the else, the second after colon, right? It goes to the customer reference and it will
It will go to this one. The moment I did something like empty string also, okay, what it will do? What will be the value of match field name? Okay, if you run this part, okay, so you have this customer number in match field name, even if it is empty. Okay, it is only checking for null for your case. Okay, so if it is not equal to null, then print me this thing. If it is equal to null, then fetch me this thing.
Right?
Yeah, empty is not null. Null is null. Okay.
Yeah, thank you.
Yeah, this is actually you'll see this code a lot in Groovy, by the way. Ternary uses. Okay, so yeah. All right. Everybody clear with this much?
Yes.
Okay. All right. Quickly, I wanted to glance on exception handling. Okay, exceptions. They work just it work for Java or other languages. Okay, so a very simple example I'll show you guys. We have something like try. Okay, so try is saying try to do some code. Okay, and if you find an exception, okay, then I'll catch it for you. Okay, so let me do one thing here. Okay, I will do print line. Okay, print line. I'll do what? I'll say 2 divided by 0. Okay, now you cannot divide a number by 0. Okay, if that happens, okay, then catch an exception. So I think arithmetic exception is there, right? Arithmetic exception.
Can you do some logic exception?
You can begin, let's write exception. E, and then you can print line here, E dot misses. Okay, this is part of the exception hierarchy, by the way. So if you run this code, okay, it is saying division by 0 because that is not. So how code execution started? Just let me show you. So it came into this try block first. Okay, it tried to run this code. If there would have been no exception, then this part will never get executed. Okay, but if there is an exception in the try block, it will go in the catch block and figure it out how to handle this properly. Okay, so okay, if I did something like 2 by 10, now that is valid, right? It will give me 0.2. It will not go in the exception block. Why do you do exceptions, by the way? To handle your errors gracefully. So what I mean by that, let's say I had print line after exception, okay? After exception, and let's also print this here, before, okay, before exception, okay? If you run this, it will tell you, okay, before exception, 0.2, after exception. Even if you are dividing by 0, okay? If you run this piece of code, it will tell you before exception, division by 0, it handled the exceptions very gracefully, and your program continued to execute. What if you didn't do this try and catch block? Okay, what if you simply did do me this thing, print line 2 upon 0. Let's first do for 2 upon 10. If you did that, it will print you 0.2. Okay, but if you did 2 by 0, it will tell you before exception got printed, and then it will tell you there's an arithmetic expression, and everything after the exceptions has occurred. Every piece of code that you wrote will not get executed. Okay, this is not at all graceful. So you have to use try and catch if you think that there can be some kind of exception that your code may throw. Okay, and so that is just a little bit about exceptions here. Okay.
What is program say e dot message, right?
Yeah.
What other things I can print with that exception? How do you know that?
We can read through API. Okay. So if I go, I'll just show 1 second. 1 second. So I can write, I know for a fact that the arithmetic exception Java API. Okay. So you can go to this one. Okay. And you have, by the way, it will show you that it is taking from Java lang exception and runtime exception, and this is this thing. And somewhere it should have something. But this may be coming from Groovy. You can see get messages there. Okay. So get message, I'll tell you in object-oriented section how get message is simply used at dot message. Okay. So if I can just get this thing here. Get rid of this thing, get message, okay, is not e dot message. It is, by the way, it is e dot get message. Okay, so that is some Groovy magic for you. Okay, it is actually every in your documentation you'll see it written as message, and this might give you some thought that this is actually some property. It will be a property, but behind the scene, it is actually calling get message method. Okay, so keep that in mind. We'll talk about that in object-oriented. All right. Any doubt? All right. Okay, let's start with collections now because we are already halfway through. Okay, collections. I'll just quickly glance over list again. Okay, the list I had declared. So let's just go define our list. This is how you do it. Okay, 1 2 3. Okay, you can print this list. Okay, you can get the list dot size. Okay, size method. Okay. If you run this piece of code, very simple, it will tell you 1 2 3 3. Okay. List have indexing from 0 to 1. sorry, 0. Their indexing start with what do you call it? 0. So this will have an index of 0. Okay. So if I can just print line here, print line. Okay. List. How do you fetch that one? You can say 0. Okay. If you want to fetch the second index, you can say 1. Okay. Another thing, important thing in Groovy that is actually not available in Java is that you have a concept of negative indexing where it starts from behind. So 3 will have a negative index of -1. Okay. So -1, you can actually do again. If you do -3, okay. So what exactly this will represent? -3.
1.
Yes, 1. So this is 1 to 3. Size is 3, and then you are using subscript operator. This is 0, 1. 1 is this. -1 is from the other side, other end of your list. Very simple operations here. One of the important one that I wanted to show is, give me 1 second. One important thing I wanted to show is this part. You can convert a range into a list. Okay, so I have a range. Let me define the range here. Okay, the range is defined this way, right? I can convert this into a new list. Okay, let me call it as range list for clarity that where it is coming from. So I can convert range into to list. Okay, and if I printed this range list, okay, and print range also. Actually, let me print line your range, and print line range list. Okay, so if you do this, let's run this thing. Range will give you just one thing. I am from 1 to 100. Okay, only when you call next on me, I will give you the next number. Okay, but list will actually take as much space as it has been given. So if I said like 100 elements are there in my list, it will take that much space in memory. Okay, so if you want to go maybe if you want to use your RAM more, maybe you can create some range, huge range, and convert that into your. So let me just show what I mean actually. Okay. So I have a range here. Okay, 1 to, let's say 1,000. This is a million. Okay, this is 10 million. Okay, and I'll fetch the size of it. Okay, using the size. Okay, if I run this code, it will tell me that okay, you have a range with a size of 10 million. Okay, so one thing I wanted to do is I wanted to show you something very cool. So 1 second. Performance. So this is your memory here. Okay. Yeah. Okay. So if you create something, this I wanted to show what actually happens when you do range versus list. Okay. So if you run this code, no, let me run this again. Control R, Control W, Control R. There is no actual fluctuation here in memory. Okay. The moment you do convert this range into a list, so let me do that for you. List. Okay. Range is, remember this huge thing. Okay. A range dot to list method. Okay. Okay. And then you did something like list dot size. Okay. If you run this and watch the memory side here, okay, this will immediately start to spike up a bit. Okay, there will be some spike here. So if I increase it by 1 further, let's say I do even more, I want to store even more number. Okay, so if I do that now, there will be immediate spike. Okay, in your memory. Okay, it will now have the RAM that you have in your system is actually this much. 100 million segments in your RAM is actually occupied now. Okay, so be very careful when you're using range. If you just want to iterate, never go for list. Okay, if you just have to iterate over a million numbers, Never go for a list. It will consume too much of your memory. Okay. So this is just I wanted to show. This is what happened behind the scene when you actually write some code. Okay. Okay. All right. Any doubt on that one? Anybody? All right. So let's actually do some basic operation that you can do on your list actually. Okay. So new list, you can do dot add. I wanted to add something here. Okay. So I add 4 to it and then I print line new list. Okay. So if you run this code, very simple, 1, 2, 3, 4 got added. Okay. There's another method actually, new list. And this is called the left shift operator, which actually works like append. Okay. So I can give 5 and then you print line your new list again and run this code. Very simple, 1, 2, 3, 4, 5. But good thing about this one is that I can do this also. 6, 7. Or what if you have a loop and you wanted to keep on adding? So you had something like, let's say, for maybe some variable I, okay, and inside your you had a list, you could do each time I will get added. Something like this also you can do. Okay. So if you do this, remember, you run this, you have 1, 2, 3, 4, 5, 6, 7. Now another way is you can add list, new list plus 8 and let's say 9. Okay. And if you print line, what will happen? Anybody?
7, 8, 9.
If you print this, no, you still have till 6, 7. Okay. So for this to work, you have to do new list equal to new list plus 8, 9. Okay. Why? Anybody can tell me?
Because you're not assigning, you're just when adding over there. I mean, it is not getting added to the list.
Yeah, that is true. But why it is getting added here and here? Right? That's the real question. Why it is getting added there and not here? Because on line number 2 and 4, it got added. We printed it and it was working fine.
We cannot add to list. No, that.
Yeah, that's actually true. In essence, that is actually true. What is happening here? If you remember that,
We are assigning value at 4 directly.
yeah, exactly. If you have, let me open this. Come on, man. Okay, so let's say you had this RAM, okay, and your list 1, the new list that you have created is here, occupied here. Okay, when you did add, no, it worked here only. Okay, even you did this left shift operator, it worked on this object. When you're doing this particular line of code, which is your new list plus 8, 9, another list, right? So your another list maybe this 8, 9 maybe at this position, right?
Yes.
You don't know, right?
Correct.
Right? And when you add this one and this one, what can happen? You don't know that it can be added here also on the next slot that is available to it. But you don't know this some other program, maybe this Microsoft Whiteboard that I'm working is occupying this. Okay. So what it exactly does, it creates a new list altogether somewhere in memory with these things, new list plus this 8, 9.
Don't know the address.
You don't know the address, so it will create on a new place. Okay. So if you did some kind of what do you call that?
Adding to lists, then
Yeah.
just creating a list.
If you did some kind of that particular thing, if I can show you this, let me quickly show that as well. Print line. Remember how we fetched the system dot identity hash code, right? And then you passed here new list. Okay. So if you do this, okay, these 3 things, okay, and if you run it for the first 2, it is same, it worked on the same memory address. The moment you added 2 different lists, it actually added them, but it created at some new place. Okay, so that is why you have to go it this way, new list equal to new list plus 8, 9. Okay, is it clear? All right. So you can also remove from list very simple steps is there. So you can remove, simply call the remove method, and you can do, let's say I want to remove this 8. Okay, so if I run this code now, print line new list. Okay, if you run this, what actually happened? What happened? By default it took by index. Okay, you can give by value also. You have to specify, I think, if you specify index equal to this thing, then it will work for that. I think this is overloaded, by the way. Remove. I think if you give value equal to 2 and then control this thing. Okay. Value equal to 2 didn't work. Value equal to 2 is not working. Okay.
Value equal to 2, also remove this index 2.
Yeah, value equal to 2 has removed the index 2. Okay, yes, that is true. How do you remove this thing? I think there should be something in API. Can somebody figure it out? This is actually removing by index. I think something should be there. If I want to remove not by index but by value. Okay. Can somebody figure that out? I'm going to leave it as it is. Okay. I'm going to discuss this. All right. So another thing that you can do, if I define a new list here, let's say, get rid of everything first of all. So I have a new list, okay, and I have A, B, something, okay. You can do something like new list minus. Maybe I want to remove some element from my list, so you can simply say minus, okay. But again, you have to assign it to a variable, to this new list variable, okay. Then only it will work, okay. So this will have just A. Other thing that you can do is you can multiply your list as well. So if you have new list as A, and if I wanted to do something like I wanted to get this list repeated for maybe 5 times, okay, then if you run this code, you have A 5 times, okay. Few methods that they are available, okay. Something like you can have many times you'll work with lists where they are less nested in nature. So you have 1, 2, and then you have something like 3, 4, okay. So this is nested list. There's a list inside of a list, okay. So you can do something like print maybe list equal to list dot flatten, okay. There's a method. These are standard API methods, okay. So if you run this piece of code, it will get flattened. Only one list now. You don't have a list of list, okay. Similarly, there is something if you're working with set theory, like in mathematics, right? So you have intersect, you have disjoint, those kind of operation are there. Do you want me to go through this? Because this is a standard examples that you can go over internet, okay. But I do want to focus on one thing. Let's say I had a random list, okay, random. Let's say I have 5 minus 2, 11, 99, minus 2, 34, maybe 33, okay. You can do something like a print line random dot sort, okay. And if you run this piece of code, it will actually sort your code, sort your list, okay. So sort is another one. Sort is one that you should know, okay. And by the way, you can do a lot here, okay, if you have more experience on closers. Yeah, I'll come to dictionary in a moment. Just 1 second. 2 more methods I'm going to discuss here. Random dot I think min will fetch you the minimum one, okay. And random dot max will fetch you the maximum if you want that. And there is one more, random dot sum, which actually gives you the sum of your list, okay. So sum is 80. This is list, standard list, nothing more nothing complicated. Anybody any doubt in this? All right. Few things I wanted to show on list. One is sometimes what you want to do is you want to iterate on your list, right? Anybody any doubt on that one? So let's say I have a list equals I wanted to do maybe 2, 9, 11, 13, something. Okay. I wanted to iterate, but I want to iterate with their index as well. Okay. So you can have, there is this standard method in their API. Okay. Each with index. Okay. And this will accept 2 parameter. Okay. And by the way, this is closer. This will call a closer. Okay. And this accepts 2 parameter. One is the value itself. Okay. And the other is the index. And then you separate it, and then you say print line. Something like dollar index has value or dollar value. Okay. And if you run this, 0 has a value of 2, 1 has a value of 9 or something. So you can use this at a lot of places in your Groovy coding. Okay. So this is done. Any doubt? Now we'll talk about sets. Sets are fairly simple. Any doubt on list, guys?
How frequently is the list used in Groovy? It's very frequent, or
it is very frequent, and if you compare it with your Java counterpart, you don't have to do this array list, linked list, all these things. You don't need to worry about those things. Okay, just you can use def, normal def, or you can use list and then work with it. Okay, simple like an array. Treat it like an array, but you can have you can add, remove. You don't have to think about indexing, whether it will go index out of bound exception or something like that. One more last thing is that lists are heterogeneous in nature. Okay, I hope that is the correct. So you can write 1, and you can have also here sort of, and you can have here maybe false. You can also have another list here, 2, 3, something. So these are heterogeneous in nature. Okay, so list gives you much more flexibility compared to your Java counterpart. Okay, let's move on to sets. Okay, anybody, any doubt? So you can have sets. You can say set s equals, and set has 2 reasons why you should be using. Okay, one is uniqueness. Okay, sets will only contain unique value. Okay, and the other thing is sets are actually very fast. Very fast. What I mean by that, searching in sets are very fast. So this will be very important when you're working with a large set of, maybe there are a million of numbers. So if you have to make the decision, maybe use a set rather than a list, because in list it will take more time, and I can show you that. But first, let's introduce sets. So I told you list sets are unique by nature. Okay. What do you think will be the size of set here?
1, 2, 3, 4, 4.
If you run this piece of code, it will be 4. And why 4? Because sets will only store unique values. So even if you have repeated 3 number times here, right? Print line s. Okay, s will have just 1, 2, 3, 4. It will only have unique values in them. Okay, and that is the only thing about set here. Okay, their notation is very similar to how you actually define your list. Just like you put your list in your square brackets separated by that comma, right? That's the only difference. The only difference I've defined is set here. Okay. In EPM, you'll see something like this thing, set of string. Okay. S equals to, they will have something like Oracle. Maybe I'll repeat it. Okay. Microsoft. Okay. And if you print your set here, print line s, I should have named it s2. I've already defined s. Oh, here. Okay, if you print this one, you have Oracle and Microsoft. Okay, but this angle bracket is actually something called generics in Java. Don't worry, this actually Groovy throws it completely, so you can add here 23, and this will not error out. Okay. So this is purely optional and used actually for developers to kind of make sense that, yeah, this is a set containing strings. Okay. So that is one thing. Set is unique by nature. Okay. And you can do some searching operation easily. So if you wanted to check whether one is there in this first one, first set, okay, then one in S, if you do this, it will say, okay, I'm there. That particular set is there. Okay, so that is there.
What is this set string?
This is I told, this is common in EPM Groovy scripting. Okay, this string is actually used something for generics in Java. Okay, but this Groovy does not care about it. In Java, if you have something like this, no, you can only have strings on this side of your assignment. Okay, but Groovy does not care. So I can write here 25 or 254, and if I run this, it is perfectly valid code. Okay. But this is just for clarity of people who are reading your code, that okay, this is a set which will only have a string in them. Okay, so uniqueness is whenever you have uniqueness, use this. And whenever you want to search something, you have some set maybe and you wanted to search for it. Do you want me to go through that code? I'll quickly go over it if that's okay. So let me define one set here. Okay, the set equals to, and again I'm going to do this. Sorry, a really big number, maybe 100 million. Is it 100 million? 3, 6, yeah. Okay, and just like we converted it to list, we can do this thing also to set, and def list equals to if you want, you can do that as well. And then let's do, this is also called benchmarking or timing your code. So you can do something like system.
What is the difference between 12 and 13? It's only the same thing, right?
It's same thing, but when I'm mentioning here set, the data type will be of for this variable will be set. And when you okay, I did this, I should have done this list. Sorry. Yeah, now it will be list. Okay. This is benchmarking your code, like timing your code, exactly. So system dot, you have this this thing defined in your system class, current millisecond. Okay, and then what I'm going to do is I'm going to search for the largest number. Okay, so this is the largest number in the set, right? This happens to be the largest number in the set. Okay, in set. Okay, and then def print line, what to print line? Well, this minus start. Okay, this is nothing fancy here. We are timing the search operation in a set, and we'll also time the search operation in our list. Okay, so I'll just repeat this piece of code. Let me get rid of this. Start is again this thing in list. Okay, let me get some more space here. All right. Let's get rid of everything here. Okay, so if you run this piece of code, it may hang also. System hang, not have tested for that big number. Has somebody written this code?
You have follow question. You put it on the pad, it will come over.
It hanged actually. Hello? Okay, let's see. Okay, that's okay.
Okay, he has put it here.
Somebody else kept?
I think he put it
Yeah, I took a snap, so I just copied. So it's not great, but at least something is better than.
I'll do one thing. I have it somewhere in my day 3 somewhere should be available. I actually benchmarked it yesterday also. So yeah, I have the code.
Okay.
Okay. So let me just take this part from here. and then Groovy. So, all right. So we can paste this and then uncomment all of it, right? And I think this is one less than the one I executed last time. Okay, so let's see. And you can see the difference right away, how fast it is actually in set compared to Groovy, sorry, compared to list. Okay, so if you just have to sets, you'll use for two purposes. One is your uniqueness, right? It only stores unique value. Even if you keep adding the same thing, it doesn't really matter to set. And the other thing is faster searching. Yeah, and it is really fast when you do it in set than in list. Okay, so there's that. Any doubt on this? This is only two things about set that I wanted to cover. Sets are very useful whenever you need uniqueness. Okay, any doubt on this thing? And if you want, you can have more thing here, like current time millisecond. There's also something like seconds or nanoseconds. If you want, go ahead with the API and go crazy. All right, we'll go with maps now, which is the last thing in your collection framework. Should I continue on maps?
Yeah.
Okay. Maps actually is a key to value collection actually. So what I mean by that, okay, what I mean exactly is this thing. So if I have, let's say, this guy works for something like Oracle, and I can have maybe this guy works for Microsoft. Okay, so it is key and value pair. Maps are nothing but key and value pair. Okay, so how do you access this? So what I mean by that, accessing, like, okay, let me give you an example of list. So we had a list here, 1, 2, 3, right? And you wanted to access the first index of it, right? So you said 0 and you got that value from here. It printed you 1. Okay, so maps is just like this, except for the 0, like here integer, you're putting index, right? You actually can define a custom key for that particular thing. So here, if I wanted to get the first value, okay, I can say something like Saurabh, okay, and this will give me Oracle. Okay, so maps are actually are key value pairs. Okay, and there are a few things how you can do it. Groovy makes it easier for you. You can also do Saurabh, and that will give you the same result. You can also do maps.Saurabh, and Groovy will tell you, okay, you're still trying to access something. But what if the key is not there? So if I wanted to give, let's say, Avinash, okay, then for this, it will actually print me null. This is null. So the reason it didn't print because it is null. Okay. So normally what happens is this throws an exception, key value, key not found error, but in Groovy, it will just give you null. Okay. If you want to add Avinash to, let's say, my dictionary, I can say Avinash, and he also works for Oracle. Okay, and then if you print your maps here, okay, Avinash should be there in this. Okay. Any doubt here? This is simple only, just like your, and the same method, by the way, size is there, the same method you can use. So I have 3 elements in my current dictionary. Okay, by the way, maps are also called dictionary in many languages. Okay, and maps in Groovy is actually linked hash map. I'm aware that many of you don't know this, but linked hash map will retain its order. Okay, that is not the case with most languages. Okay, dictionary by default do not maintain order. Okay, so if I print this, if I print the map here, okay, run this thing, it will always print in this way because it is behind the scene linked hash map. If you do it in other language, you can get this Saurabh Oracle at the very end and Avinash Oracle at the start. You don't know which sequence you'll get. Okay.
Can you sort it based on the index?
Yes, you can do it. I'll have to write the code for that. Okay. You can do that. You can do anything. Let's go through one quick example of simple. So you can say if I wanted to get the keys from a map as a Because remember, one thing I wanted to discuss here is that keys are actually unique. Okay, the moment you say Avinash to maybe Amazon or something, okay, and it won't add here Avinash and Amazon. Okay, it will replace this because the keys, which is the first thing in your key value pair, is going to be unique always. Okay, so one second. So if I did something like maps and then I said Avinash and then I said Amazon, right? And then if you run this maps again, then it will have Avinash will have Amazon. Okay, because the key cannot be duplicated. Okay,
And
so
I can iterate for like for loop.
I'll show it. I'll show it. So few important thing here. If I wanted to get the list of keys that I have in my dictionary, okay, you can do. They have APIs defined for that. So you can do keys. Sorry, the keys equals maps dot key set. Okay, and if you run this, you'll get only the keys. Okay. You also have something called as the values. If you just wanted the values, okay, maps dot values, okay, and if you run this, you'll get a list of values which is there. Okay, let's do a few things here. So we can iterate, obviously. So we have the maps, and then we can use closures again, which is, and let's, if you use just one variable, by the way, and this is overloaded, and what I mean by that I'll show you. If you just use one variable, so I'll show here, one second. Dollar entry dot key works for dollar entry dot value. Okay, if you run this code, you'll get, so also Oracle, this guy works for Microsoft, I'm not work for Amazon. Okay, so you can do this, but you can also just iterate on, let me clear this drawing that I have first. One second. Okay, you can also iterate on just this thing, you just the keys or just the value. So you can do something like maps dot each. Okay, and here you can give key comma val maps. By the way, this is actually a closer. Okay, key comma val. Okay, and you can print a similar thing here. Okay, only that it will only accept here key and here only val. Okay, and if you run this, what happened? No source property. Okay, I'm giving value, you should give val. Okay, so again you can say this, so you have the option of just using entry, and then if you just use one variable, you have to use entry dot key or entry dot value. If you use two variable, you can separately get key and value. Okay, again we have showed this key set and values. So if you just wanted to iterate on key set, use this. Okay, you can say for key in keys, and then you'll work on that. And if you wanted to iterate on just values, you can iterate like that. Okay, if you want to remove some element, let's say I want to remove something from my map. Okay, very simple method is there, remove. Okay, and you can give the key. I want to give key as this, and then if you run your maps again, then your map has only now two key value pairs. Okay, so any doubt here till this point? I have actually one question with me that I wanted to, I'll assign that as homework. If somebody wants to do it, they can do it. So I had this response from an API which comes as a list. Okay, and you can see that I have only two snapshots here. I have snapshot 1 and there is snapshot 2. Snapshot 1 has a lot of parts, part 1 through 11. Snapshot 2 does not have any part, it is single. Okay, what I want to do I'll give you this on email after this session is over. Okay, what I want to do, I want to fetch the size of snapshot 1 and snapshot 2. So I know for a fact that snapshot 2 is just having value of 80, which is 80 MB, but snapshot 1 is actually separated into 10, 11 parts. Okay, so you will need to add this all part, and then just maybe results would be something like, let's say, snapshot 1 is equal to, is having a size of 101, and snapshot 2 having a size of 80. Okay, so do this. This will be a very good exercise for you if you can do this thing. Okay, all right. Okay, everybody clear with mapping, maps and dictionary?
Yeah,
Saurabh,
yes.
Yeah, sorry.
Yeah, Parani, continue. Yeah.
No, I said yes. That's it.
Okay.
No, Saurabh, so one doubt here. So maps dot each in the 22nd line
Yeah,
is directly taking key and value. So how
yeah.
it is the values here? So it is directly getting the values of
So you are passing the maps directly here, right?
yes, maps dot each.
Yeah, so when you pass maps, no, this is actually a method on the this maps. Okay, this is defined in their API, and this is overloaded. I'll talk about overloading maybe tomorrow when we talk about object oriented. What overloading exactly means, that you can have the same method name, okay, but it can have different parameter list. Okay, so here when you see something on line number 18, when you pass the maps, I'm just passing one argument to the closer, which is entry. And inside that, I'm saying, hey, give me entry.key and entry.value.
So
Okay.
here I understood it's a 19th statement. So you have given key and value. So here it is taken
Yeah.
as total methods. Like it has a method and it is taking the values key as and value.
Yeah.
Here you do not mention any key and value here, but how it is fetching the data here. So that is what I'm
So
I did not
when I
understand
do,
24.
yeah, when I do this thing, no, key comma value. Okay.
Mhm.
Okay. So just 1 second. Let me create one small map for you. Okay. A is having a value of 1, and B is having a value of 2. Okay. Nothing fancy here. H. Okay. And when I say entry here, okay, print line, entry. Okay. What do you think this code will print?
First and second.
It will print you first A equals to 1 and B equals to 2. Okay. Because entry, oh God, entry is this one whole.
Okay, one whole thing. Okay.
Entry is one whole thing. Okay. This entry, this is taken as entry. Okay. Simple.
Okay.
When I say something like this here, key comma val, okay, let me actually show that also so that it is clear for everyone. When I do something like, I'll take this example only, okay, and I did something like k comma v, okay, print line $k and $v, okay. When you do something like this, no, when you do something like key comma v, okay, for the first one that you had, this one here, entry, it took this as combined total. Think of this as entry also, this two together as an entry, but behind the scene what it is doing, it is separating key and value in its own. Okay, so entry, when you took entry here, you took this whole thing. Okay, when you're doing this thing, you are still taking this whole thing, but the Groovy is smart enough to figure out, okay, I'm taking two things, but I have defined two variables here. So one I'll associate with key, one I'll associate with value. Okay.
Okay.
Yeah. So if you run this part, sorry. If you run this piece of code, these two pieces of code, okay, first is A equal to 1, B equal to 2, that is coming from your entry. And here I have defined $key. Maybe I'll do one thing is I'll say separator so that you actually feel that where it is coming from. All right, so it's still entry only, But when you define two things, Groovy is smart enough to figure out, okay, I'll take K as key, V as value. Okay.
Instead of one, you're taking two variables.
Yeah, instead of one, you're taking two. Okay.
Okay. So when you're taking one value, we're explicitly saying the key and value in the 18th statement.
Yeah, you have to mention here explicit. This is actually overloaded and very common across programming languages when you're working with dictionary or maps. Okay, very common. They actually give you this the kind of overloaded method where if you just wanted to work on entry, that's fine with us. If you want with to work on key and value of an entry, then you have this presented in the API as well.
So sorry, the dot key and dot value are the like standard words or like standard keywords in the 18th line. Can you go to the 18th line?
Yeah, here no dot key and dot value. It is again. Can I just tell you that this is actually get key method being called? Okay.
Okay.
Rather than
Get key, get value.
yeah. Maybe it's not there. Get key is not there. So they have this is their parameter only. It's a method is not there. So you have to check documentation for that.
But it is parameter. Okay.
It is a parameter. Very common. This is why Groovy sometimes confuses people. All right. Let me just get rid of this. Everybody clear with maps? Any doubt, guys? No? Okay. I just want to show as last thing, and then we can wrap up to this session. This is just going to take maybe a couple of minutes only. So, do you want me to do file handling today, or is it? Okay. Okay. So first thing, I'll just very simple example I'll take is working with dates, and we have seen how you can work with dates earlier also when we defined a range for dates. Okay, so let's say I want to have so my question is, my current scenario is run certain automation every Monday for the next maybe 90 days. Okay, this is my question. Okay, so this is not exactly how you code, but on a high level overview, this will get you started. So you can do the new date will give you the current date. So let me actually, before doing this, if you want to get the date for today, okay, you can say new date. Okay, and this will give you the date for today. So it is saying, okay, Monday, March 6th, this thing. Okay, if you wanted to get date for yesterday, what you can do? New date. We have already defined today. So today minus 1. Okay, and if you want to get date for tomorrow, okay, so today plus 1. Okay, and you can print all of this. So this will print for tomorrow, which is 7, I think. If you comment this line of code, if you run this will print for yesterday one, which was Sunday. Okay, so just adding and subtracting will give you the date for the next day. And this is very convenient. Actually, when you're working with code, just think of Groovy. Okay, because this is not available in all the languages. All right, so let's get rid of this thing. Okay. I am defining I have a loop here. Okay, and I want to iterate from today to exactly how many days? 90 days, right?
So can you use a variable to understand, right? Instead of writing it for you.
Okay, so let me define today first. Today equal to new date. This will fetch me today, right? So I'll just write here today, and remember this is a range, right? So today plus 90. Okay, and this is also important here. I talked about precedence. Range has a very low precedence. Okay, so first this will get executed, and then this will work together as a range. So it will not be like today to today only. It will be like today to today plus 90. Okay, so yeah, you can just print line here, date first, print line date. Okay, something, what happened?
Or you are writing the date.
in. Okay, I forgot the in part. Okay, and this actually prints you all the dates from today all the way through 90 days, and that is June 4. Okay, so I want to run a certain automation on a particular every Monday, and that is my intention. Okay, so again, you have to go through API of dates and calendar to figure out what exactly the method you need. Okay, but for my case, this will work. So if date dot get day, and this get day is actually for Sunday it is 0, for Monday it is 1, for Tuesday it is 2, like that you will get that response. So if that is there, I'll say print line what dollar date. Okay, and I would say run certain automation. Maybe you can write code inside of this if block, something like that. So if you run this now, okay, it is saying from now till the next 90 days, it is telling, okay, today is Monday. So you run automation today after 7 days, and every Monday you'll actually run certain automation. So this is how you can actually work with dates. Nothing too much to talk about really. But this part you have to figure out on your own, like how you can use certain API. So go through the documentation of that, and that will make it clear. Okay. Any doubt on that? Anybody? Okay. Okay, so simple stuff is left now, which is our file handling. Okay, file handling is very simple. Groovy makes it extremely easy. Okay, so first we'll see how we can write to read a file. Okay, and then we'll see how to write to a file as well. One thing I wanted to do first is, because 1 second, I want to close this current session on console. I want to actually work inside, because this is where my files will be there, so that it is able to pick it up. So you can create a certain folder and maybe create some random file. I'll call it as sample.txt, and inside this I'll have, this is line 1, right? Line 2, third is third line, something. Okay, I don't even care about this, that, whatever. Okay, in. All right, so this is my sample text. Okay, and here only I'll open my CMD, and from there I'll open Groovy console, so that we have access to the file. All right. Okay. So first thing, okay, you can give here file path also. Okay, so string file path is going to be, for my case, is going to be sample.txt. Okay, if you have defined in some other directory, then you have to specify path here, full path. Okay, for my case, it is in the current directory. Okay, so first thing first, how do you create a file object? We'll say file equals to new file. Okay, and you give the file path in this constructor. Okay, and we'll talk about constructor tomorrow, but this is how you actually start reading your file. Okay, so how can you read your file? Well, you can say file.text. Okay, and if you run this code, it will just print you, okay, this is line 1, line 2, whatever I've written will come in this one. Okay, you can get this in list also, the content of your file in list. Many of time we actually desire that the content of file is actually stored in a list. So you can say something like list equal to file dot collect, right? And this is, by the way, this is again on file. If you see this, this is your file object, right? And this collect is actually an method in their API, which actually takes your closer. Yeah, so one at a time. So if I just pass this implicit one, okay, and then if you print line list, okay, then you have this as a list. Okay, this initially this actually printed it as a text one. Okay, but this you can create as a list also. Okay. Any doubt on this one? You can also do one thing. You can, if you want to iterate on your file and you want to use line number, okay, then you have a method for that as well. So you have each line, and here this is again closer line number, right? And then you separate this and you say print line, and here you can give dollar line number and then maybe dash dollar line. Okay, I don't want to do this here as well. So let's run this part. Okay, and line number one has this thing. If you want to iterate in that fashion, okay. One other thing you can do is, let's say I'm interested in, you have massive lines, okay, massive file, and you want to work for certain line numbers. So you can create a range first. You can create something like range of, sorry, of, oh, come on, range of lines, and I want to iterate from where exactly? Well, I want to iterate from 6 to 9, okay? So I can give here the 6 through 9, okay? And then let's define a list which will actually store my values there, okay? And you can say file dot each, using the same one that we have used here, each line, okay? File dot each line. Line, comma, line number, nothing fancy here. If line number in range of list, range of lines, okay, I'm only interested in that part, okay. So for that I want to do this, print me that one, okay. Or maybe not just print that, maybe add it to a list if you want to do that further processing. So you can just do this list line, okay, and then you can print line your list as well. So if you run this, obviously, let me just comment this part. Okay, let me run this again. Yeah, from 6 to 9 we actually got this, and we also got it in a list. Okay, so this is one way of how you can use ranges, lists, and files all together to actually achieve something that you want. Okay. Okay, any doubt there? Okay, Groovy has provided some very fascinating methods. So
Are you also to show how to write to a file?
yeah, I'll show it. That is also ridiculously simple. We'll write to a file, we'll append to a file. Just give me 5-10 minutes, this will be over. Okay. The few of the standard things that you can do is print line something. If I want to figure it out whether this is, what is the size of this thing, like we have been using size a lot, right? So it is telling this is a 4 bytes. Okay, it will be in bytes. Okay, it will be in bytes. Okay, then you can also, sorry, this is list, I told you, no. File dot size. So it is of 62 bytes, and you can go and check there if you want to check that file sizes there are not similar. So you can also do print line whether a file is file or not, whether it is directory, because I'll show you why that is the case. Print line file dot is directory. Okay, if you run these things, it will say, okay, I'm file, but I'm not a directory. And why is the case like that? Because in Groovy, whether you're working on file or directory, you have to create your object this way only. It is always called file. So whether you're working on file or directory, you will name it that way only. Okay. So one good example, let me show something good example. So I have here, let's say, let me pick a let me pick one particular, let's say I want to pick something. Let's say I'm picking this particular maybe I'll pick this. Yeah. Okay. Let's pick a dictionary, and inside a dictionary we will try to search for a particular file. Okay, how we can do something like that? Okay, So let me get rid of everything from here to here. And even I told you, even when you're working with directory or file, you have to specify object like new file only. Okay, so this is my new file. Okay, and on that we have a number of methods that we can call. So I'm particularly interested in each file method. Okay, and here what you can do is file. Okay, and print line file dot name. Okay, and if you run this code, there is some error that you're getting. Can somebody tell me why that error is coming?
So directory, not a file.
No, that is not the issue.
Okay.
When you are specifying path, no, you should always try to give it either double slash to escape that one, or you can give this slash. So I actually prefer this. Okay. Use forward slash so that it also works on your Linux system. Okay, now if you run this, okay, I have these three things. Okay, I have these three things inside of my that folder. Where is that? So .git diaz is something like .git ignore is there. So three things are there. So it printed me all those strings. So there is also one more method. So I'll just copy this, which is even more interesting. Is you can recursively search inside also. So the only change that will happen is we'll use the each file recurs. Okay, rather than each file, we'll print each file recurs, and this will actually print a lot of things because I have a lot of something is there. A lot of files are there inside. Okay, so this actually goes inside. So let's say I want to search whether a certain file is available or not. Okay, in certain directory. So you can give any directory here. Okay, so if I want to search for that, how can I do that? Well, if file dot name equal to which one? Able to this thing, right? You can write here print line something found dollar file dot name at location and dollar file dot get absolute. These are in their API, so I highly recommend you checking all these things. Okay, so I'm searching only for that particular variables.py file. Okay, so if I run this piece of code, if you run this, yeah, so what happened? No such property get absolute path. Oh, why is this error coming? Can somebody tell me? Anybody? I know it's past 6, but
File name dot
no.
file dot name.
I told you when you're evaluating expression, always put a curly braces. Okay. While this is not, you can put it here also. Okay. And if you run this time it should work. Okay. So actually let me get rid of this so that it is clear for everyone. Found variables.py at location, this one. So if you want to search a particular file in a directory recursively also, this is a very good way how you can achieve it. And you can also do something like find me file something like dot ends with, okay, ends with .py extension. So give me all the files that ends with .py extension. Why not? Okay. So if you run this, again, I did something wrong. Okay, this is a method, so you have to give something like this, ends with this thing. Okay. If you run this, so there are so many .py files. So it is found configuration features.py at this one, found cubes.py, whatever. Okay. So if you want to search for certain file extensions, you can do that as well. Okay. All right. Is it clear for everyone? All right. So one last thing I wanted to discuss is how you can write to a file, and this is actually the last thing. So just stay for 5 more minutes and it will be over. Write to a file. Okay. So again, you have to define like that only. File equals to new file, right? And I want to make it data.txt. Okay. So you can do file dot write. Write is the method that you'll use, and you have to write this is line 1 in data.txt. Okay. If you write again line 2, what do you think when I will run this code will happen? Okay. If I run this code and go back to check my directory here, you have data.txt created already. Okay, if you open this, it is only showing line 2. Why is that? Well, write is actually overwriting. Okay, if you wanted to append, okay, if you wanted to append, you can do this thing. Okay, and now if you run this code and go back to your date3 1 data.txt, it is showing this is line 1 in data.txt, and then line 2 is also there. If you want to add new line, you have to specify explicitly here that I do want new lines here. Okay, so if you now run this piece of code and go back to your data.txt file, you'll see this is line 1 in data.txt, line 2 in data. So this is one thing, and also you can use the left shift operator for adding to your file. So I can say line 3/n, /n, and then you can go crazy line 4, line 34 maybe, and then /n. Okay, and if you run this piece of code, go back to your this particular thing, data.txt, you can figure it out there as well. One last thing I do want to discuss is that you can actually rename your file in Groovy itself. Okay, so you can do something like file, because we are working with data.txt, I'm going to rename it to Groovy dot maybe txt. Okay, and if I run this piece of code and go back to my it will be groovy.txt, not data.txt. Okay, so yeah, that is how you actually write to a file in Groovy. I think I'm done with today's session. I'll stop the recording.